One of the first things we'll always want to do with any particular family of functions is to consider what the graphs of those functions look like. And here we're not going to go into a lot of detail about how to graph these. We're just going to consider the basic shapes of the graphs. And of course, we know that when we have a family of functions, every graph in that family has the same basic shape. It's just in a different place relative to the axes. So here I've graphed the functions x to the third, x to the fifth, and x to the seventh. And just to get a better idea of the shapes, I've also graphed negative x to the third, negative x to the fifth, and negative x to the seventh. Notice that switching the sign of the output just vertically flips the graph. I think we can see why that happens. And so looking at this set of graphs on the left, we notice that the general shape of these graphs is like an S shape or maybe a Z shape. And these are the functions that we get when we have an odd exponent. So odd exponents give an S-shaped or a Z-shaped graph. On the other hand, looking at the graphs on the right, where I have x squared and negative x squared, x to the fourth and negative x to the fourth, x to the sixth and negative x to the sixth. These graphs are, they go down and then up again, or up and then down again. Right? We say that these are like U-shaped curves or N-shaped curves. And so looking at these graphs on the right, we see that even exponents give, I'm going to say that this is a U-shaped curve. This is a lowercase n-shaped curve. So they give a U-shaped or n-shaped graph. Now, you might be thinking the word parabola. Some, but not all of these graphs are parabolas. We'll talk more about parabolas a little bit later. For now, though, be aware that not all of these U-shaped or N-shaped curves are the shape called a parabola. And the key difference to notice between the different powers is that while each graph is flat near 0, 0, the larger the exponent, the sort of flatter the graph becomes. On the other hand, for x values that are far away from 0, the graph is either increasing or decreasing really quickly. And so we see right out here, far away from 0, we have graphs that are very steep. Right, when x is far away from 0, we have a graph that is increasing or decreasing really quickly. And just like the flattening near 0, the extreme steepness far away from 0 is also stronger for larger exponents. And then the other thing that we also noticed is, right, when we add that negative sign, when we add the negative sign to the output, the effect is to flip the graph vertically. So the Z-shaped curve becomes an S-shaped curve. The U-shaped curve becomes an N-shaped curve. So again, we just want to think for the moment about the general shapes that these graphs have. We'll learn a general technique later on in the course that will let us graph them much more nicely. But for now, we're just interested in the general shape.